So today's objective is we want to find the proportion of observations from the standard normal distribution, but I want to add a twist in that we're going to use the calculator to compute the proportions instead of using the blue charts, the paper charts, okay? There are two different methods to do this. We've spent the past couple days working on doing these kinds of problems from your chart. Now I want to show you a way that we can do this with technology. These are the exact notes. I'm going to use our notes that we did the other day to model how we can do this in the calculator. Okay, and then it's going to be up to you. It's your personal preference what method you like to do this. So what we want to do is we want to take this first example, example 3. All right, we already found the answer to be 0.9767. We wanted to find the area under the curve to the left of 1.99. A way that we can do this, if I open up a scratch pad, okay, in my calculator, is you can choose menu, and then we're going to go to statistics, distributions. And we're working on the normal curve. This year, we're going to literally do this entire menu, right? This whole menu here we're going to do. Right? Oh, except a couple, this one right here, we don't do F. Everything else we do. So what we're going to do is we're going to work right now. All we've learned so far is the normal curve. We are going to choose normal CDF. We will never choose normal PDF. Okay, and I'll explain that a little better later when it'll make more sense. But right now, what we're going to do is we're going to pick normal CDF. This is a cumulative distribution. Okay, so C for cumulative distribution. We're going to pick normal cumulative. Now, this is always going to ask us the same couple questions. What is our lower bound? Which means where does our shading start? What is our upper bound? Where does our shading stop? Okay, and then our mean and our standard deviation. Keep in mind that whenever you're working with a z-score, the mean is 0 and the standard deviation is 1. This is already going to be inputted in as your default of negative infinity. This is their way of writing negative infinity. Yes, the calculator has an infinity symbol. If you found it, it's with pi, but you cannot put the infinity symbol in here. You need to pick a very large number or an incredibly small number, negative 9999999 to do that. But they already input negative infinity if you want that. So if you go back to your notes, our shading starts at negative infinity and our shading stops at 1.99. So I already have starting at negative infinity. I'm going to have it stop at 1.99. Mean of 0, standard deviation of 1. You press OK. And there's our answer, 0.9767. If you choose this method, you need to write down norm CDF parenthesis. On paper, you can handwrite negative infinity. You can do the negative infinity symbol when you're writing it, comma, 1.99 for you would write LB underneath for lower bound, UB for upper bound, mean of 0, standard deviation of 1. So you'd put the standard deviation symbol and mu underneath. There you go, that's your answer. So what we just did is we bypassed looking it up on the chart and let the calculator look it up on the chart for us. And you say, well, Ms. McMichael, the chart's fast. It is fast. But if you take a look here at number 4, for this problem, our shading started at 1.11 and our shading stopped at positive infinity. So if I come back here, I'm going to go back again, menu, statistics, distributions, norm CDF. My shading starts at 1. What was it? I have to look it up again. 1. And my shading stops at positive infinity. So I'm going to pick a big number. I just pick 55555, right? Or 4,000. Compared to 1, 4,000 is huge. Yes, I know it's not infinity, but it's a huge number. Okay, compared to 1. My mean is 0. My standard deviation is 1 because this is a z-score. I press OK. Notice 0.1335. Our answer last time was 0.1335. What the calculator does is the calculator takes care of, do I need to subtract or not? It does that for you and just gives you the final answer. And that is what's really cool. So for example 5, you're going to do norm CDF. Our lower bound is negative infinity. Our upper bound is negative 1.75. So you go menu, Now, notice, guys, you can just hit the 6 button for stats. You can hit the 5 button for distributions, and you can hit the 2 button for norm CDF. You don't have to scroll through them. Okay, so you pick the 2, negative infinity. Where the shading stops is negative 1.75. Press OK. We have 0.0401, right? Be careful that you're going to round if you're supposed to round, just like we had back here, 0.0401. Number 6 is where it gets super cool, right? Our shading is between negative 2.48 and negative 0.83. Shading starts, shading stops. So if we come back, menus, problem stats, come on, distributions, our shading starts at negative 2.48. Our shading stops at negative 0.83. This time, it looks them both up and subtracts them for us, which is so awesome. So if you choose to do this by hand, totally fine. You're going to look up negative 2.48. You're going to look up the area for negative 0.83. You're going to subtract those two areas like we did here and get your final answer. But if you use the calculator, it's going to handle that for you and just get you straight to the final answer. Now, the other type of problem we handled is find the z-score. So if we're finding the z-score that has 20% of the observations above it, this is where you still need to figure out the left. So just like with the paper chart, you need to always look up the area from negative infinity up to the line. Okay, same idea with the calculator, but this time what we're going to do, we're going to do a little change. We're going to go menu, stats, distributions, but this time we're going to pick inverse normal. We're going the opposite way. We're inverting our process. So since we're inverting our process, inverse normal, this is going to ask you, what's the area? This area always stands for negative infinity up to the line. So the problem we just had, negative infinity up to the line, the area was 0.8000. You can include the zeros, but you don't need to. And then a mean of 0, standard deviation of 1. What it gives you, this is actually the z-score answer. Right? The z-score for an area of 0.8 from the left, the z-score is 0.84. And if you take a look at our notes, that was our answer. Our answer was z equals 0.84. So number 9, find the z-score that has 70% of the observations above it. Here's your top 70, but the calculator, just like the chart, needs from negative infinity up to the line. So the calculator needs this 0.3. So I'm going to come back here. I'm going to go menu, stats, distributions, inverse normal, and my area is 0.3. Oh, silly me. I had it on. I had my cursor on the other thing. Sorry, guys. Stats, distributions, inverse norm. The area is 0.3. Okay, press OK. And there we go. Our z-score is negative 0.52. And if we go back, our z-score for that problem was negative 0.52. So let's say that we have a word problem, all right, like this. Well, how can we handle that? So what you're going to do for problem 10 is you're still going to find your z-score, right? You're still going to find your z-score to be 0.74. And then your z-score would be here, 0.74. Then you'd use your calculator to do normal CDF. Okay, our shading starts at negative infinity. Our shading goes up to positive 0.74. So we would come back here. No, hang on. I'm going to have the same mistake I had before. There we go. There's my cursor. So I'm going to have menu, statistics, distributions, norm CDF, lower bound negative infinity, upper bound. For number 10, the z-score we found by hand using the formula was 0.74. All right. Mean of 0, standard deviation of 1. I'm not using the mean and the standard deviation from the word problem because the number I just typed in was the z-score. If the number you type in is the z-score, z-scores always have a mean of 0, a standard deviation of 1. I press OK. Here's my answer, 0.77035. Well, what we had found yesterday or previously was the same answer, 0.7704 instead of 0.035. This is just the rounded answer. All right. To do a problem like, so you would just write norm CDF and then parenthesis, everything that you just had from the calculator. You would write this down on your worksheet, on your paper. The College Board accepts this as long as you put underneath LB for lower bound, UB for upper bound, mu, and sigma. You have to state what the items are in your calculator speak. Okay, in your calculator writing, you have to write down what things are representing. If you just put calculator talk with no explanation or symbols matching what's what, you will not earn full credit on the AP exam. And I grade the same protocol as the College Board grading, okay? Now, if we take a look at the next guy, number 11, this is one where we were starting with a percentage. When you start with a percentage, that's when you use inverse norm. So we're going to have, if it's the top 10%, we need this area, 0.90. So we're going to go in the calculator, menu, stats, distributions. We're going to pick inverse normal. The area is 0.9. Mean of 0, standard deviation of 1. Press OK. This is my z-score. Inverse norm gives you an answer of z-score. Z equals 1.28. So if it's z equals 1.28, that's what you would do. So up here, you'd write inverse norm, the parentheses stuff, equals 1.28. Then you plug that in, and you still do this and get your answer. All right, we will have lots more practice to work on.